Hello, my name is Ronan Soriano, and right now we're going to talk about the Chapter 1 Introduction to Statistics. So, what is statistics? It is a collection of methods for planning experiments, obtaining data, and then analyzing, interpreting, and drawing conclusions based on the data. So, what is a data? Data are characteristic or information, usually numerical, that are collected through observation. In a more technical sense, data is a set of values of qualitative or quantitative variables about one or more persons or objects, while a datum, a singular of data, is a single value of a single variable. So what is a variable? A variable is a characteristic or condition that can change or take on different values. Most research begins with general questions about the relationship between the two variables for a specific group of individuals. So what is a population? The entire group of individuals is called the population. For example, a researcher may be interested in the relation between class size, which is the variable 1, and academic performance, which is the variable 2, for the population of third grade children. So what is a sample? Usually, populations are so large that a researcher cannot examine the entire group. Therefore, a sample is selected to represent the population in a research study. The goal is to use the result obtained from the sample to help answer questions about the population. From the population, all of the individuals of interest, to the sample selected from the population, to the individuals selected to participate in the research study, to the result from the sample are generalized to the population. It is a cycle which keeps on repeating. So what are the types of variables? Variables can be classified as discrete or continuous. Discrete variables such as class size, it consists of indivisible categories, and continuous variables such as time or weight are infinitely divisible into whatever units a researcher may choose. For example, time can be measured to the nearest minute, second, half second, and etc. So, discrete variable, it is a variable whose value is obtained by counting. For example, number of planets around the sun, number of students in a class. It is a range of the specified number is complete. It assumes a distinct or separate value. Continuous variable. It is a variable whose value is obtained by measuring. For example, number of stars in space, height or weight of the student in a particular class. Range of specified numbers is incomplete. It assumes any value between two values. Discrete variable is a variable which cannot theoretically assume any value between two given numbers. For example, number of accidents in a month, number of children in a family, number of students in a class. A continuous variable is a variable which can assume any possible value in a range. For example, weight, temperature, and age. What is a real limits? To define the units for a continuous variable, a researcher must use real limits, which are boundaries located exactly halfway between adjacent categories. So we're gonna measure the variables. To establish relationship between variables, researcher must observe the variables and record their observations. This requires that the variables be measured. The process of measuring a variable requires a set of categories called a scale of measurement, and a process that classifies each individual into one category. So, these are the 4 types of measurement scales. 1. A nominal scales is an unordered set of categories identified only by name. Nominal measurements only permits you to determine whether 2 individuals are the same or different. For example, nominal data includes eye color and country of birth. Nominal data can be broken down again into 3 categories. Nominal with order. Some nominal data can be subcategorized in orders such as cold, warm, hot, and very hot. Nominal without order. Nominal data can be subcategorized as without order such as male and female. Dichotomous. Dichotomous data is defined by having only 2 categories or levels such as yes or no. Number 2. The ordinal scale of measurement. An ordinal scale is an ordered set of categories. Ordinal measurement tells you the direction of difference between 2 individuals. An example of this kind of data looking to satisfaction data points in a survey were 1. Happy, 2. Neutral, and 3. Unhappy. Where someone finished in a race also described ordinal data, where the first place, second place, or third place shows that what order the runners finished in. It doesn't specify how far the first place finisher was in front of the second place finisher. Number 3. An interval scale is an ordered series of equal-sized categories. Interval measurements identify the directions and magnitude of a difference. The 0 point is located arbitrarily on an interval scale. 4. Ratio scale. It is an interval scale where a value of 0 indicates none of the variable. Ratio measurement identify the direction and magnitude of differences and allow ratio comparison of measurements. So, nominal scale used for naming variables in no particular order. For example, eye color. Interval scale used for numerical variables with no equal intervals of the same distance. For example, time. Ordinal scale is for variables in wrong order but the difference between is not determined. For example, 1. Happy, 2. Neutral, 3. Unhappy. Ratio scale used for variables on a scale that have measurement interval. For example, weight. So, what is a correlational studies? The goal of correlational studies is to determine whether there is a relationship between 2 variables to describe the relationship. A correlational study simply observes the 2 variables as they exist naturally. Descriptive statistics. Descriptive statistics are methods for organizing and summarizing data. For example, tables or graphs are used to organize and descriptive values such as the average score are used to summarize data. A descriptive value for a population is called a parameter. This descriptive value, for example, is called a statistic. Inferential statistics. Inferential statistics are methods for using sample data to make general conclusions about the populations. Because a sample is typically only a part of the whole population, sample data provide only limited information about the population. As a result, sample statistics are generally imperfect representatives of the corresponding population parameters. Sampling error. The discrepancy between a sample statistic and the population parameter is called sampling error. Defining and measuring sampling error is a large part of inferential statistics. different random sampling. Probability sampling involves a random selection allowing you to make strong statistical inference about the whole group. Probability sampling involves non-random selection based on convenience or other criteria, allowing you to easily collect data. Sample size. The number of individuals usually included in your sample depends on various factors, including the size, variability, the population, and your research design. There are different sample size calculators and formulas depending on what you want to achieve with statistical analysis. Simple random sampling. In a simple random sample, every member of the population has an equal chance of being selected. Your sampling frame should include the whole population. To conduct this type of sampling, you can use tools like random numbers, generators, or other techniques that are based entirely on chance. For example, you want to select a simple random sample, 100 employees of company X. You assign a number to every employee in the company database from 1 to 1000, and use a random number generator to select 100 numbers. Systemic sampling is similar to simple random sampling, but is usually slightly easier to conduct. Every member of the population is listed with a number, but instead of randomly generating numbers, individuals are chosen at regular intervals. For example, all employees of the company are listed in alphabetical order. From the first 10 numbers, you randomly select a starting point, number 6. From number 6 onwards, every 10 person on the list is selected, 6, 16, 26, 36, and so on, and you end up with a sample of 100 people. Stratified sampling. It involves dividing the population into subpopulations that may differ in important ways. It allows you to draw more precise conclusions by ensuring that every subgroup is properly represented in the sample. To use this sampling method, you divide the population into subgroups called the strata, based on their relevant characteristic, for example, gender, age, range, income bracket, or job. Based on the overall proportions of the population, you calculate how many people should be sampled from each group. Then, you use your random or systemic sampling to select a sample from each subgroup. For example, the company has 800 female employees and 200 male employees. You want to ensure that the sample reflects the gender balance of the company. So you sort the population into strata based on gender. Then you use random sampling for each group, selecting 80 women and 80 men, which gives you a representative of 100 people. Cluster sampling also involves dividing the population into subgroups, but each subgroup should have similar characteristics to the whole sample, instead of having sampling individuals from each subgroup. You randomly select the entire subgroup. If it is practically possible, you might include every individual from each sample cluster. If the cluster themselves are large, you can also sample individuals from within each cluster using one of the techniques above. This is called multi-stage sampling. This method is good for dealing with large dispersed populations, but there is more risk of errors in the sample, as there could be substantial difference between clusters. It is difficult to guarantee that the sample cluster are really representative of the whole population. For example, the company has offices in 10 cities across the country, all with roughly the same number of employees in similar roles. You don't have the capacity to travel to every office to collect your data, so you use your random sampling to select 3 offices. These are your clusters. So that's all for now. Hope you learn a lot with chapter 1. Thank you and goodbye.